Hey everybody, it's Ripley back again. Today we're going to talk about derivatives of trigonometric functions. By the end of today, you are going to know how to take the derivative of the sine of x, the derivative of the cosine of x, and then you're probably like, well, Ripley, if I combine that with things like product and quotient rule, doesn't that give me the derivative of the tangent of x, the derivative of the cotangent of x, the derivative of secant of x, and then the derivative of the cosecant of x. I probably could have written these up in advance, right? But I don't know. I don't have that cooking show feel to me today. All right? So these six, these are going to be vocabs. You are going to have to memorize them. No options. All right? You have to memorize them. If you don't, you suffer at your own hands, which is silly. Put them on flashcards. At this point, you're starting to get a lot of derivatives. You've got derivatives of x to the n. You've got the derivatives, excuse me, you've got the derivatives of products and quotients and derivatives of exponentials, all that good stuff. So you want to make sure that you're keeping track of it because it's going to get overwhelming. All right, so let's start with the derivative of the sine of x. So I'm going to find the derivative of the sine of x. Because once we got this, believe it or not, once we have the derivative of sine and cos, then it's really easy to figure out the others. Okay, and really we're only going to do the derivative of sine. Well, I guess we can do the derivative of cos too. I'm feeling kind of saucy today. So all right, first things first, hopefully you realize that this is just the limit as h goes to 0 of the sine of x plus h minus the sine of x all over h. That is by definition the derivative, excuse me, that is by definition the derivative of sine. Okay, so let's go ahead and take a gander at this thing. Well, the first thing I'm going to do is I'm going to look at this thing and I'm going to be like, oh, well, okay, well, what am I going to do? Oh, wait, there's a sum and difference formula. First, there is a sum and difference formula for sine. So if I take the limit, if I apply that from pre-trig, or from pre-calc, excuse me, this becomes the sine of x cosine of h plus the sine of h cosine of x minus sine of x all over h. Now, why am I doing this? Well, because as h goes to 0, this becomes sine x minus sine x, which is 0, over 0. Over here, do I need to keep doing stuff? Well, yeah, because let's look. This becomes what? As h goes to 0, this is 1, so I get sine x. As h goes to 0, this is 0, so that's 0. So I get sine x minus sine x, which is 0, over 0. Crud. Got to keep working. So let's do a little bit of algebra here, and let's see what happens. So what do I want to do? I'm going to factor out, what should I factor out? Well, let's look, if I group these two terms right here, can't I write this as the limit as h goes to 0 of sine of x times cosine of h minus 1 over h, right? Common denominator, plus the limit as h goes to 0 of cosine of x times sine of h over h. True? Now look close. Make sure I didn't do anything fancy. If I group this term with this term, they both contain a sine of x. So I factored those out. What was left was a cosine of h minus 1. That's where this guy came from. And then the limit of the sum is the sum of the limits. So the thing that was left over was this guy right here. Now, I'm already digging this because this is going to be sine of x limit as h goes to 0 of cosine of h minus 1 over h plus cosine of x times the limit as h goes to 0 of sine of h over h. Now, if you recall, remember our very first limit that we learned pretty much was the limit as h approaches 0 of sine h over h is 1. So I know this is going to turn into the sine of x limit as h goes to 0 of cosine of h minus 1 over h plus the cosine of x. Because this guy right here, it's a good thing I'm changing colors anyways. I'm going to do something different here. This guy right here, well, I guess this whole limit goes to 1. So this cosine of x is on its own from this point hence. It is not subject to the limit. So maybe I'll put this guy in parentheses so we don't think that the cosine of x is subject to h as h goes to 0. Now, if I plug h in, I get cosine of h or cosine of, if I plug 0 in, excuse me, I get cosine of 0 is 1. 1 minus 1 is, crud. So I've got a little bit of algebraic two-steppery to do here. So let's do that really quickly because I got to figure out what this thing is. So this is going to be sine of x limit as h goes to 0. Now, whatever should I do? Well, if you recall, we played around with this with limits back in the last few sections. Really, the only thing that I can figure out to do is to, let's multiply through by the conjugate, right? So I'm going to multiply through by cosine of h plus 1 over cosine of h plus 1. It's just a goofy looking 1, and nobody ever got in trouble for that, right? So I'm going to go cosine of h minus 1 over h times the cosine of h plus 1 over the cosine of h plus 1. Since the limit of the product is the product of the limit, we're good. Remember this little plus cos x over here. This guy's just cruising along over here. All right, happy little guy. Now this becomes sine of x, limit as h goes to 0, of cosine squared h minus 1 over h cosine of h plus 1, and then let's not forget our cosine x over here, cosine x. Now, cosine squared x minus 1, what is that? Well, 1 minus cosine squared is sine squared. So if I flip that, don't I get a negative sine squared? Don't I? I mean, isn't that good? So let's look at that. You may be going like, Ripley, what are you talking about? Well, look, limit. Again, I'm just using my pre-calculus Pythagorean identities. 1 minus cos squared is sine squared. So cos squared minus 1 is negative sine squared h, right, over h times cosine of h plus 1. And then don't forget your plus cos x. Now, look close. Watch. If I stick h equals 0 in, this can be rewritten as sine of, this is going to be ugly. I'm going to pull the negative out in front because it's a constant. I'm going to take the limit as h goes to 0, excuse me, of sine h over h times sine of h over cosine of h plus 1. You see what I did there? Pulled the negative out front. The sine x is a constant, left it along for the ride. Don't forget our plus cos x. Now what happens here? Well, the limit of a product is the product of the limits. I know the limit as h goes to 0 of sine h over h. This is going to give me a 1. I know that the limit as h goes to 0 of sine h is 0, and the limit as h goes to 0 of cosine h is 1. So this becomes 0 over 2, which is 0. Everything cancels, and guess what I get? I get cosine of x. The derivative of the sine of x is cosine of x. Now, I can go through the whole thing again, but you guys are going to want to poke your eyes and ears out for not wanting to listen to me. I can go through this whole process, but with cos, or you can take my word for it, knowing that it's basically the same thing that I'm going to do. It's more or less the same trick. It's a little quicker and a little more elegant, but we can maybe leave that to you for a project or extra credit or something like that down the road. This guy, the derivative of this, is negative sine of x. Okay? All right, so the derivative of sine is cos. Derivative of cos is negative sine. There's a little trick here. Whenever you're taking the derivative of something with a cos, cosine, cotangent, cosecant, you're always going to have a negative, all right? Which I can prove to you here in just a sec. But believe it or not, you're like, I know you're going, Ripley, I swear if you make me go through this limit definition for all of the other trigs, I'm going to lose my freaking mind. Hey, guess what? You don't have to worry about that. Guess why? Well, it's pretty simple. Because if I want to take the derivative, I don't know why it does that. It's so weird. It only does it some of the time. Of tangent, this is just the derivative of sine x over cos x. And guess what we have? We have the quotient rule. So this is low d high, which is cosine of x, times the cosine of x, minus high d low, which is sine of x, times negative sine of x, all over low squared, which is cosine squared x. Well, if you look close, what's this turn into? Cos squared minus a negative sine squared. That's cosine squared plus sine squared. That's the Pythagorean identity that we ever learned. It's 1 over cos squared x. And guess what you have? You have secant squared x. So the derivative of tangent is secant squared x. Similarly, watch this. If I want to take the derivative of cotan, of x. Well, watch what happens. Whoops, cotan of x. This is equal to the derivative of cosine of x over sine of x. I want to prove where that negative comes from on this guy. Wow, my writing is going downhill. Low d high, right, which is going to give me a negative sine squared x minus high d low, right, minus high d low, which is going to be minus cos squared x, all over low, whoops, sine squared x, all over low squared. Factor out your negative, and guess what you get? You get negative 1 over sine squared x, which is negative cosecant squared x. Doink! So this is negative cosecant squared x. All right, let's do secant. I promised you we were going to do all of them. So derivative of secant. We won't do the very last one. All right, you can. You're going to hate me if I do that. This is the derivative of 1 over cosine of x. Well, we're going to use product rule, right? It's just a product. So low d high, which is going to be cosine of x, times 0, minus high, which is 1, times d low, which is negative sine of x, right? Derivative of cosine is negative sine. You're going to have to memorize those. Put them on flashcards. This is all over low squared, which is cosine squared x. Well, negatives cancel. Cosine of x times 0 is 0. And guess what I get? I get sine of x over cosine squared x. Now, you may be looking at that being like, oh, that doesn't seem very easy to remember. Well, it isn't. However, if I write this as sine of x over cos x times 1 over cos x, just using a little fancy schmancy algebra, well, guess what I get? I get tangent of x times the secant of x. Whoa, crazy. So what I end up with is the derivative of secant of x is secant of x, tangent of x. Now, you might be able to guess what the derivative of cosecant is, and you could prove it down the road for yourself if you wanted to, but it's negative cosecant of x, cotangent of x. And guess what? We got all 6, as promised. See, I'm good for my word. All right, I hope that was helpful. Those are the derivatives of all the trig functions. Didn't take too long, hopefully wasn't too painful. However, I beseech you, please, in the name of all that's good and holy, make flashcards. Put this on one side, put that on the other. This on one side, that on the other. This on one side, this on the other. You with me? This, you're gonna hate me. This on one side, this on the other. Okay? All right. Hopefully that was helpful. Make your flashcards. Have a glorious day, and I'll see you in the next section.